Let me do this integral by three methods. Well, the integral itself is not difficult, but the methods we are exploring matters, because once you master the basic techniques, and you can explore the more complicated integrals. So let me try the first method here. The first method is by using substitution. Let square root x be u. Obviously, we want to get rid of the square root, so x equal to u square. So this becomes arcsine u, and square root x is u, square root 1 minus u square, and 2u du, isn't it? And x from 0 to 1, no difference. Now then you cancel out. Okay, this becomes 2 taking out, 0 to 1, and arcsine u over 1 minus u squared du. Well, this one over 1 minus u squared is the derivative of arcsine, right? Arcsine u. There's a 2 here. Sorry. So this one is equal to, this will be half, right? 2 times half arcsine u squared, isn't it? From 0 to 1. So this will be here. Arcsine u square from 0 to 1. This will be pi square over 4, isn't it? So that is the result from method 1. Okay? Now method 2. From 0 to 1, arcsine square root over x, 1 minus x dx. Now this method starts with the substitution. Let theta be arcsine square root x. Therefore, square root x is equal to sine theta. Isn't it? So our integral is equal to, this will be theta, dx will be d sine square theta, isn't it? The sine square theta. And square root, this is arcsine. Now, square root x is sine x, sine theta minus 1 minus sine square theta. Okay, the boundary has been changed. 0, 1 is half pi. Okay, then this is equal to from 0 to half pi. This is sine, right? This is cosine. This is theta. This is 2 sine theta, cosine theta, d theta. That is d sine square theta. So this is cancel out. So this is equal to 2 theta, right? From 0 to half pi. So this is theta square, right? So it end up with pi square over 4. It's the same answer. That's method 2. Now method 3, from 0 to 1, arc sine square root dx square root x, 1 minus x. Now for this one, well, you must be familiar with the composite function derivatives. The arc sine square root derivative with respect to x is equal to 1 over 1 minus x, right? That is the square of square root x, multiplied by the derivative of this function, which is 1 over 2 square root, and then times dx, isn't it? So this is equal to 2 square root x, 1 minus x dx. So that is equal to this. Now, if I have this, then I can have that. So I almost have that, just missing a 2. So this one is equal to 2 integral arc sine d arc sine. This one is equal to this. And when you multiply by 2, you get that. So this was a 2 from 0 to 1, huh? So 2 times half arc sine square from 0 to 1. See? Once you see this point, you can have the answer right away. So this is arc sine square root square from 0 to 1. So this is equal to half pi square. So right away, you have the answer if you see that. If you see this derivative is equal to this. This is equal to that. So after multiply 2, you have the original integral. Okay, that is okay. They're easy integral, but the methods, that will make your techniques much better, when you deal with calculus. Thank you.